Saxon Algebra 2, Lesson 99. We are going to talk about absolute value inequalities today. Inequalities implies number line, but let's just refresh our memories on absolute values. Remember that absolute value is measuring something interesting and a little different. Draw yourself a number line, put 0 in the middle, roughly, and then go out to +3 and -3. We say, when we talk about absolute values, we say that the absolute value of 3 equals 3, but we say that the absolute value of -3 is also 3. What is that all about? What we're saying is that 3 is the distance between 3 and 0. We say that 3 is also the distance between -3 and 0. We're measuring the distance from the number to 0. So that is why it doesn't matter if you're on the negative side or the positive side. Technically, I wish I'd written those the other way around, right? What this shows us is that absolute value means how many steps is it from this number to 0. And that's why both of these have the measure of 3, because it's 3 units to 0 for both of these numbers. All right, that's what absolute value measures. So now let's apply that to a graphing problem. Graph the absolute value of x is less than or equal to 4, domain equals the integers, right? It's this kind of a problem. All right, so what I'm going to do is I'm going to show you the quick and easy way you can solve these problems. Later, we will talk about the mathematical steps that led us to this, but right now I'm going to give you the shortcut and I'm going to ask you to practice using it, and trust me that later we'll talk about why this shortcut makes sense. When we see an absolute value marker, we know that that implies there are two values, positive and negative. So we know it's not just one inequality, it's technically two. Here's the way we do them. To create the first inequality, we just drop the absolute value signs. X is less than or equal to 4. To do the other one, we take off the absolute value signs, but then we flip the sign and we put a minus sign in front of the number. I flipped that and I multiplied that by -1. Now we have two normal looking inequalities and we graph those. All right, so that's how we split the absolute value into two separate equations, reflecting the fact that absolute value problems always have two answers. This is the quick and easy way to do it. We're just simplifying some algebra is all we're doing. All right, so now all we have to do is graph this. We're graphing the integers. So we know that the number has to be less than 4, but also greater than -4. And we are including 4 as part of our solution because of that equal sign down there. I'm going to put 5 on just to show that we're not doing it. And I have to draw in all the in-between numbers. -3, -2. Graphing the integers is so much more work. All right? So we want it to be less than or equal to 4, but also greater than or equal to -4. So we're going to graph all these dots in between. Integers always means graphing the dots, right? And we'll do real numbers in a minute and remember how those work. This is the solution to this problem. I like to have the inequalities included as part of the solution. So there it is. That's the whole thing. Let's do another one. There are 5 of these in all. They're quick though. 99.2. All right, this time we're supposed to graph minus absolute value of x, domain equals the integers again. Now, before we do our absolute value split, we're gonna clean up first. And what I mean by that is, let's get this algebra taken care of. That minus sign doesn't belong there, and this minus 3 needs to go to the other side. So let's start by kicking him to the curb. We'll have absolute value minus the absolute value of x is greater than minus 3. Now we have to multiply or divide by minus 1 to get rid of that. And you know what that means. Whenever we multiply or divide, we have to flip that. So this cancels that out, absolute value of x. Now it's less than, and that becomes positive 3. And now we're ready to split this into 2. For the first one, we just flick those off. X is less than 3. And for the other ones, we flick them off, but then we reverse and we multiply by minus 1. So this then becomes x is greater than minus 3. There are our two inequalities that we want to graph. We're still doing integers, so that's dots. I'm going to put 0 in the middle. 1, 2, 3, 4, 5. And 1, 2, 3, 4, 5 to the negatives. All right, we need them to be less than 3. That means we don't include 3. So we start at 2, and we're going down. And we need them to be greater than minus 3. So we can't include that. So there's our solution. It's the dudes in the middle. And I would box all of this for my answer. Yay! That's the right answer. 99.3. Get my light lined up so I don't have as many shadows. 99.3 looks like this. And this time the domain equals the reals. That means that we can choose any real number, fractions, decimals, all those little itty bitty things in between. We get to include all of them. That means we're doing arrows, not dots. All right, we've got a lot going on there, but remember we clean it up first before we split the absolute value. So let's subtract the number. This time I'll multiply by minus 1. You can do it either way. Both of them will flip the sign. This makes this a positive absolute value of x, and that makes that a positive 4. Okay, great. Now we're ready to split. It's nice and clean. So we just flick them off for the first one. And then for the other one, we take the x, we flick them off again, but this time we reverse that, and we multiply that by minus 1. Okay, so there are our two inequalities we're going to graph. Don't have to draw as many marks with this one. Here's the negative 4, here's the positive 4. And, oh, this time they're going in an opposite direction, right? It's greater than positive 4, and it's less than negative 4. I'm drawing an open circle because it does not include the value 4, right? There's no equal sign under these. So we draw an open circle here to say not 4 exactly, but all the little bitty numbers right up close to it. This is our final answer. All right, beautiful. Now that we've got the hang of this, the next two problems are, I don't want to say they're tricks, but they're interesting scenarios that kind of blow our minds a little bit, defy the rules. They're tricky, they're not actual tricks. All right, 99.4, we have an A and a B. Let's start with A. Graph. Now, when we see after the algebra is done and the inequality is all cleaned up, not in the beginning, but at the end of our algebra work, if we see a negative number over here, we pay close attention. We're looking for numbers whose absolute value is less than -2. Now think about that for a minute. Absolute values we just covered at the beginning of this lesson. Absolute values are always positive numbers, right? Because they measure the distance from 0 to the number. So they're always positive. So how are you ever going to find a number whose absolute value is less than -2? You're not. All right, so another way of saying this is that all absolute values are positive numbers. So the solution to this is either the empty set, no, this is the empty set, this is the null set, or no solution. You can write any one of those. Check with your instructor whenever you're dealing with somebody new, but in my classes, I accept all three of those as equally legitimate ways of expressing this, and I like to see all three because it shows that you understand, yeah, no, it doesn't work. All right, let's look at part B, which is also a nifty little trick. Part B is absolute value of x is greater than -2. Domain equals the reals. And once again, after the algebra is done, if you see a negative number in your inequality, pay attention. This time we're saying that we're looking for values of x so that the absolute values are greater than this negative number. Any number is going to have an absolute value greater than -2 because all absolute values are positive numbers. So this rule helps us with this situation too. And this is the way we would draw the solution to this one. I kind of like to make it a little bit thicker and then cross it in so that somebody can see, essentially you're highlighting the entire number line. All values for x. Anything you can imagine. X can be any real number. So that's our solution, all right? You don't have to write the words, you just draw that picture, all right? So what triggers these two trick situations is that after the algebra is done and the inequality is cleaned up, you have a negative number in your inequality. That triggers either this scenario or this scenario, right? It's either nothing or everything, depending on which way the inequality is pointing. So the trick to watch out for is not in the beginning, but after you've done the algebra, there's a negative number there. All right, and then our last example illustrates this really nicely. 99.5 graph domain equals the integers again. We're back to our dots. Now, after having just taught that lesson, some students might look at this and go, oh look, there's a negative right there in our inequality on the other side of the sign. That means it's a trick situation. No, because look, we have a bunch of algebra we have to clean up first. So we wait until after that's done to decide if we have a trick situation. So let's add 5 minus absolute value of x is greater than positive 2. Now our brains might say, oh look, it's fine, it's not negative after all. But then we multiply or divide by minus 1. We're gonna flip that. Now we get positive absolute value of x is less than minus 2. Oh, now we see that minus sign took us back to a trick situation, right? So we thought we had a trick, then we didn't have a trick. Don't even think about it until you get it all cleaned up. Now that we have it all cleaned up, we can see we're looking for values for x whose absolute value is less than a negative number. No, everything we choose for x is going to be a positive number, so there is no solution for this one. This is the type A, right? It's like this one, right? No numbers have an absolute value that's less than negative 2 or any negative number. Pound sign used to mean number. Walk back through the mists of time with me. All right, so this is just like our A scenario in the last problem. There are no numbers whose absolute value is less than negative 2. So that's what we put for an answer. Yay! All right, that is the end of lesson 99. I will see you next time for the landmark lesson number 100. Thank you. Goodbye.